Okay, we begin here by subtracting x from both sides to get the radical by itself. Then you have radical 3x equals 6 minus x. And we can square both sides. This gives us 3x is equal to 36 minus 2 times 6 times x is 12x plus x times x is x squared. Then we need to subtract 3x from both sides. This gives us x squared minus 15x plus 36 is equal to 0. Okay, so now let's use the quadratic formula to solve this. X equals the opposite of, well, we don't need the quadratic formula, we can factor this one. This one factors as x x minus times x minus. And the product is 36 and the sum is 15, so it looks like 3 times 12 will do the trick. And so from this one we get that x equals 3, and that's or x equals 12. So those are the two solutions to this equation. We have to check them though before we can be sure. So when x is 3 plus the square root of 3 times 3, that's the square root of 9. 3 plus 3 is 6, so that checks out okay. So this is a valid solution. And at 12, 3 times 12 is 36, so that's 6. This one doesn't seem to work, does it? Let's take a look in detail here, this one, to check. So it's 12 plus the square root of 3 times 12 equal to 6. That doesn't seem very likely, does it? It's impossible. In fact, this is 36, so 6 does not equal 6. So this possible solution didn't work, but that one did. So we have one valid solution to that equation. X equals 3. Okay, for number 96, they wanted us to write that as a complex number. Well, as a complex number then we have negative 21 over 7 plus radical negative 5 over 7. We can split it up like that. And the negative under the radical becomes an I outside of it. And so we end up with 7 goes to negative 21 negative 3 times, plus I times the square root of 5 over 7. So there we have it written as a complex number with real part negative 3 and imaginary part radical 5 over 7. In problem number 97, to add these two complex numbers, you just add the real parts and add the imaginary parts. It's really 3 minus I plus 5 plus 2i, and 3 plus 5 adds up to 8, and negative I plus 2i adds up to I. So 8 plus I is that sum of complex numbers. For number 98, we have to use the FOIL method here. So foiling it out in that order, we have 3 times 5 is 15. then 3 times 2i is 6i, then negative I times 5 is negative 5i, and negative I times 2i is negative 2i squared. And then you can see the two middle terms. We have 15 and plus 6i, minus 5i is just 1i, and minus 2i squared, remember that I squared equals negative 1. That's the strange property of I. So this is really plus 2 because of that. So what we end up having is 17, 15 plus 2 is 17 plus I. So there's the solution to that product of two complex numbers. Finally, for problem 99, we're to simplify this expression. So, first, write 64 as a power of 2. And then you multiply the two exponents. And the 6's cancel. You're left with 2 to the 5th, which is 32.